Okay, now we move forward to the second set of the question. Okay, so the second set of the question actually concern on the shop that has only single door. So this single door has an entry sensor at the outside and a push button at the inside. So the idea is basically the same thing, the same one with set 1. So if you write down the input and output, we will have a start button, a stop button, an entry sensor, exit, push button. Okay, and then output should be a solenoid and pilot lamp. Okay, so there are two pilot lamp, which is full and please wait. Okay, so if we start putting the address first, then we can, we can proceed further. Okay, so say 100.00, 100.01 and 100.02. Okay, so this is the input and output. The requirement is if it is less than 12, okay, the solenoid will be on, okay, which is unlocked. Equals to 12, solenoid is off, and then two lights will be on. Okay, and we should also initialize the register when we press start. Okay, so the same way as the first question. So I have a start button. I have a start button and then a stop button. I connect to an internal register. So remember, put your address here. Okay, and then the internal register will activate a differentiate bit. Okay, so this differentiate bit 40.00 will initialize the register. Say the register is D0 again. Okay, now we have entry sensor, which is 0.02, and entry sensor should increase the accumulator or the register. Okay, so you can use plus D0 H1 D0. Okay, and exit push button is 0.03. It's also minus D0. Okay. Okay, and then we do a comparison. So when we connect the 10.00, okay, this IR here, 10.00 to a comparison block, that means that for every single program cycle, we will compare the register with the value 12. Okay, alright, so the comparison block will affect the flag. Okay, so if it is less than 12, we know that we need to open the door, or solenoid should be on. Not open the door, unlock the door. Okay, and if it is equal to 12, then we need to display a full sign as well as a please wait sign. Okay, alright, so this one is 100.00, 100.01, 100.02. So just to make sure that you have a consistent labeling on the input and output as well as the ladder diagram. Okay, so this will take care of the requirements from the input. You can see that we have 4 inputs and 3 outputs. So 4 input is basically the start, stop, entry and exit. And we have 3 outputs: solenoid, full lamp and please wait. So if you have catered all the input and output, and also catered down on the requirement, then it's gonna be fine, okay? Or as long as it doesn't have to look exactly like mine, but as long as you cater the important requirements, which is initialization, um, and then comparison, okay, and then the light up of each of the output according to the correct flag, then it's going to be fine.